Good afternoon, everybody, and welcome to the IFE Yorkshire and Humberside monthly webinar. Today we have a guest presenter discussing the magic numbers and golden rules. But first, I just need to read out the IFE disclaimer before we start. So, any views or opinions expressed or implied on any matters by the authors, presenters, or participants during or in connection with the content of this webinar are solely the views of the authors of the respective comments and/or opinions and must not be taken to be the views, position, or policies of the IFE. The IFE makes no representations, warranties, or assurances and accepts no responsibility for the content and/or accuracy of this resource. The IFE shall not be liable for any damages, including, without limitation, direct, indirect, incidental, special, punitive, or consequential damages that result in any way from your use or reliance on any content of this resource. So welcome everybody. Today's presenter is Ben Mossop, who is a senior fire engineer for the London Fire Brigade. Ben is also the Vice President of the IFE London branch. Ben is currently focusing on work relating to the new regulatory regime for higher risk buildings under the Building Safety Regulator. Ben's areas of expertise include active fire protection systems and transport and infrastructure projects. Ben was also a member of the technical panel which drafted the BS 9992 2020, the new code of practice for fire safety in the design, management and use of rail infrastructure, and he is here today to present on fire and rescue service access and facilities, magic numbers and golden rules. Welcome, Ben. I'll hand you over to Ben now.
Thank you, Tia. Appreciate the introduction. And in addition to the IFE disclaimer, I will say, even though these slides are all branded London Fire Brigade, none of my views should be taken to be the views of London Fire Brigade either. Although, quite possibly should represent the views of London Fire Brigade. And I've got my cup of Yorkshire tea, so I'm ready to go. And it's good to see people joining. And I hear a lot of the attendees are from Yorkshire Fire and Rescue Service, some maybe from Staff's Fire and Rescue. So welcome to my colleagues, and then welcome to everyone else, and to anyone who's joining on the recording later on as well. You will get access to this recording via the IFE CPD portal in the usual place, so you'll be able to see the slides there as well. I've got more time than I've had to give versions of this presentation in the past, so I'll try and slow down a bit, but we've got some time for Q&A at the end, so by all means throw in any questions. But if you've got questions, some of these presentations we've had questions which are sort of along the lines of, I've got this building regs consultation, how would you approach this thing? Or I've got this building and I need to contact someone. Well, in those cases, by all means contact your local fire and rescue service. That's not really the purpose of the Q&A for this. It's really, if you've got questions relating to the topic matter, which are not specific to a premises or project, then I'll try my best to answer what I can. So, Tia's already given an introduction to me. I'm part of a growing team of fire engineers in London Fire Brigade. When I first joined the team back in 2017, there were about 7 people in the team, including me. There's now about 31 of us. Someone just joined us today, so it is a growing team. A lot of our work now is focused on work around high-risk buildings and the Building Safety Regulator, and we're balancing that along with a lot of our other work streams. So it's challenging times, but also exciting times in terms of changes in our industry. And I know we're all working together to change the culture of the industry post-Grenfell. And an important part of that is understanding what is the source of a lot of the guidance that we have. Why is it important? So that's where I think it's really important to understand this concept of magic numbers and golden rules. And one area where that is particularly important is relating to fire and rescue service access and facilities. So that's really the key objectives for today. I want to really, and if a lot of you are from a fire and rescue service background, you should appreciate this already, but it's really understanding. As is the case in London, a lot of people working in our prevention and protection teams don't have an operational firefighting background. I don't myself. Everything I've had to understand in this area, I've had to learn, and it's been a learning curve over many years, and including when I worked in building control prior to this, and mechanical and electrical services, building services design before that. And so you might wonder why have someone who's not got that background presenting on this topic when, you know, London Fire Brigade alone has 4,500 odd firefighters and officers. Well, I think it's useful. Hopefully I'm able to act a bit like a bit of a translator, in that I've had to learn topic myself, and as an outsider in a sense, including before I worked for a fire and rescue service. And really, I think a really important foundational principle is our firefighters aren't invincible. There can be a perception that firefighters can sort of do anything and everything with the equipment and training they have, and actually they can only do that with the aid of the safe systems of work and a properly designed built environment. So that's the first kind of key learning objective, I suppose. And the second one is understanding where some of these magic rules, magic numbers and golden rules come from, and why they're relevant or perhaps less relevant today. So I think it is important to give a caveat here, in that fire and rescue services aren't all alike. There are a lot of commonalities. That's not just within the UK and across the UK, but across Europe and globally. You'll find you can speak to a firefighter anywhere in the world, and there's certain things that they will all have in common. We will all have in common, but equally, there are a lot of variations. And even just within the UK, equipment and appliances do vary quite a bit, both between metropolitan and rural fire and rescue services, but also even just within different metropolitan brigades. There are different crewing models, so you might be familiar already that you can, in most, or I think in pretty much every fire and rescue service apart from London, you've got a mixture of whole time, so full-time firefighters. Not to say they might not have second jobs when they're off shift, but when they're working, they are a full-time firefighter, and you've got retained firefighters who respond to, they're essentially on call. They respond to their pages, whether they're in their workplace. They have to be within about 4 minutes of a fire station, or when they're off, they're not working and they're responding from home all hours of the day. They get the same kind of training, they get the same types of equipment, but ultimately the crewing model is different. And so that varies. In London, we're fortunate to have a entirely whole-time workforce. That's largely relating to the needs of the size of London and the varying risks that we have. Water supply access also varies quite a lot, and this is particularly a difference between rural and urban brigades. You know, in London, in most places, you've got access to fire hydrants within the expected distances, though they don't always provide the amount of water required. But in other parts of the country, you might have to have tankers deliver water. You may have to use emergency water supplies from lakes and rivers and so on. So that is also something that varies. Firefighting tactics do vary also between different fire and rescue services. So it's just important to keep all of that in mind, especially with some of the examples I'm going to give, because the amount of resource we might send to an incident in London is simply not what a fire and rescue service elsewhere in the country might be able to send, perhaps in a place like Glasgow or Manchester, Liverpool, and so on. There'll be a more comparable response, but in London we have 155 pump appliances and 102 fire stations plus a river station, and it's larger than what you expect elsewhere in the UK, except for Scottish Fire and Rescue Services, where across the whole of Scotland they're the largest fire and rescue service. In London, I believe we're still the busiest. But so really, if in doubt, you need to speak to your local fire and rescue service and ask. And some fire and rescue services do produce guidance notes, additional guidance, which gives different explanation of the details of their particular appliances and access requirements. So in London, we produce a thing called Guidance Note 29. And that, for example, if you look at the appliance weights and dimensions that are given in Approved Document B or in BS 9999, we give our equivalents of those, and they do differ quite a lot. I'll explain a bit later some of the appliances we use, and we have, for example, a 64-meter. We have 3 64-meter turntable ladders. They weigh 32 tons. That's quite different from what Approved Document B shows. And our pump appliances are now getting heavier as well with our zero emissions pump appliance electric vehicles. So the myth of the indestructible firefighter, I think there's a lot of cultural reference to firefighting. It varies in terms of how realistic it is, but there's an element of this understanding of a firefighter as a heroic figure who is sort of able to do things that the average human being can't do. And Backdraft's kind of an old example. It's just that the poster kind of encapsulates this a bit. But even in more recent cultural portrayals, inevitably for the sake of drama, there's an element of fiction and poetic license, artistic license going on, which you'd expect. But it's really important to ask ourselves, do we have unrealistic cultural expectations of what firefighters and their equipment can do? Essentially, firefighters are ordinary people doing an extraordinary job. That's a phrase you might have heard, but it's even if in a sense you know that, particularly if you work for a fire and rescue service or you are a firefighter, it's keeping that in mind at all times, particularly when you're thinking about built environment design. Firefighters really rely on a combination of safe systems of work and dynamic risk assessments, and you cannot make safe systems of work refers to the systems whereby you essentially try and reduce risk as much as possible. We're never going to eliminate risk entirely from the work of firefighters, and it's a dynamic environment that firefighters work in, and so you can't simply decide firefighters can't simply decide this is what we're going to find when we arrive at an incident. It's an evolving environment, and there's a lot of changing risk even just within the scope of a single incident, whether it's a fire or one of the many other types of incidents that our firefighters respond to. And I suppose it's a poignant reminder of how hazardous a profession our fire and rescue services are, that fire and firefighters do. It's the recent fire at Bicester Motion, Oxfordshire, back in May, still being investigated, of course, where very sadly our colleagues Martin Sadler and Jenny Logan lost their lives alongside a member of the public. Martin worked both as a retained firefighter in Oxfordshire, but also as a leading firefighter in London. And his funeral takes place at the end of this month, so it's very, very fresh, the loss. And Jenny Logan's funeral took place recently. She was a retained firefighter in Oxfordshire. So just a reminder, really, that firefighting, whilst perhaps is in many ways safer than it used to be in the past, it's still very hazardous, and there's a limit to what we can do to ensure complete safety for our firefighters. So to give an example of what firefighters have to contend with, apologies, the image probably, well, it doesn't represent the diversity of fire and rescue services. Apologies for that. I do keep, every time I give a presentation like this and I use this image, I think I need to go out and get a better picture taken in terms of just showcasing the fact that firefighters aren't all white men anymore. But leaving that aside, and what it shows is essentially the initial minimum response for a high-rise fire in London Fire Brigade. We send a lot more, as I'll explain in a minute, we send a lot more resource to a high-rise fire, but just to be able to intervene, undertake initial search and rescue, undertake initial firefighting, we essentially need to take quite a lot of equipment to the bridgehead. I'm not going to be able to explain the operational procedures for high-rise firefighting in a whole lot of detail. If you're attending the IFE Elevate presentation on operational firefighting tomorrow, I'll go into that in a bit more detail there. And apologies, there will be some repetition from some of what I've talked about today, but hopefully that's useful repetition. But in terms of the equipment firefighters have to carry, well, so at minimum we'd have 4 firefighters, 2 of whom would be breathing apparatus, whereas it's harder to see in this picture, but these 2 firefighters are wearing standard duration breathing apparatus. We also have extended duration breathing apparatus, which weighs more than this, but just the weight of personal protective equipment, so boots, leggings, tunic, helmet, that alone, and gloves, weighs approximately, it's heavy, and then combined with a standard duration breathing apparatus set, you're looking at already about 25 kilos without carrying any other additional equipment. And then if you add in, as an example, so these 2 firefighters, as well as their BA and PPE, they're carrying 2 lengths of 45mm hose, which weighs about 9.5 kilos uncharged. So that's another 19 kilos. Other types of bits of equipment, such as the fire bag, which I'll show in a minute, the fire incident response equipment bag, that working way around 16 kilos. So when you add all that up, you're looking at 45 kilos. So you imagine carrying that over a long distance. You imagine doing that on a hot summer's day. Very quickly you realize that it's quite physiologically demanding to do this. And that's leaving aside actually entering a fire compartment, having to move casualties, those aspects which only make the job harder. So that's something to bear in mind when thinking about building design, or when you're evaluating, say, a building regulations consultation. Somebody wants to extend the travel distances that firefighters have to go, even outside a building, even outside of fire conditions. We often see this, and I've shown an example later on with a podium type arrangement. We've seen proposals expecting firefighters to climb some stairs, walk 100 meters before they even reach the entrance to, say, a block of flats, to intervene in an incident. And that may seem relatively trivial. You're designing a building and you're not thinking about the physiological demands for firefighters, but when you consider the amount of weight being carried, you consider factors such as, recently we've had a bit of a heat wave. It's 30 degrees, and we're only going to get hotter weather with climate change going forward. Straight away, you've got firefighters who are under some physiological strain. Their core body temperature is going to be rising, and that's before they've even entered a fire compartment. It's just another view. This picture's a bit old, but there's a lot of it stands, I think. The way we roll the hose used for high-rise operations has evolved a bit. We use Cleveland roll rather than Dutch rolled hose now, which makes it easier to maneuver and unroll at the bridgehead. But we carry, so if you look, so this firefighter's carrying this green bag, which is a immediate emergency care pack. So essentially a first aid kit. It's got a defibrillator, oxygen cylinder, range of sort of standard first aid equipment. And that's just as much something we would use if we recover a casualty who needs immediate first aid before we can transfer them to the ambulance service. But equally, if a firefighter becomes injured, it's critical equipment. We bring hose. We bring forcible entry equipment, various types of forcible entry equipment. This is what we call a Halligan bar, which is used, sometimes called a hooligan bar, I believe, in the UK, and US, developed in the United States, and so it's a versatile tool for forcible entry, and it's an enforcer ram, which you might see police officers using in some circumstances. We bring, so now the branches or nozzles, which work with the hoses, now come as part of this first fire incident response equipment bag, which contains a range of useful equipment. It includes things such as a range of tools and keys. It includes tags that can be put on doors to show that we've searched a compartment. Includes a replacement spindle and wheel for a dry riser outlet, for example. Useful equipment because those get stolen and vandalized and so on. So to make our lives easier, we've got this equipment bag which we bring at around 16 kilos. There's a controlled dividing breaching. So if you don't have a double landing valve outlet, which some fire and rescue services ask for example, Kent asks for those. If you don't have that in a building, then you've got a way to attach two hose lines to a single fire main outlet on a single level, for example. And then obviously this breathing apparatus, it's just standard duration. I don't know if we always bring the guidelines now, which can be useful in large compartments but then firefighters often use hose to find their way back. Thermal imaging cameras are quite a critical tool. There's a thing called a forward information board, which is used just to help record information at the bridgehead location, and an entry control board, which is for control of breathing apparatus, essentially, which is a key part of the safety system for making sure that we keep track of firefighters wearing breathing apparatus. So I don't expect you to understand what all of that is if you don't already, but it's just really the message I'm trying to get across is there's a lot of equipment, and firefighters have to get that to work in a high-rise incident. From the ground, if you don't have a firefighter's lift because it's either out of service or the building's not quite that tall, this has all got to be carried upstairs. So it gives you a further idea of some of the associated physiological demands. What do we mean when we're talking about magic numbers and golden rules? I think it's worth introducing that a little bit if you haven't heard of this before. I do very strongly recommend to anyone who's working for a fire and rescue service, so as a fire engineer, anyone who's a fire industry professional really, but particularly if you have anything to do with fire engineering or reviewing performance-based designs, strongly recommend in particular, well, all of the work of Margaret Law and Arup very kindly made these selected papers available for free. So if you go to that URL, you'll be able to download the whole document. It's about 100 megabytes, and there's lots of excellent papers in there. One particular paper, which is what I'll be making some reference to today, was titled Magic Numbers and Golden Rules. It was a presentation that Margaret Law and Paula Beaver of Arup Fire at the time gave to the International Association for Fire Safety Science conference in Ottawa in Canada, 1994. And I'm not going to give a spoiler on what the baby in the Buick refers to, but I would do. It's a short paper. I do recommend reading it, and you'll find out. But I'm not going to give you too many spoilers, otherwise you won't go and read it. But anyway, this is where the concept of magic numbers and golden rules, and the fact that you do need to understand what is the intent of guidance and these numbers we have, where do they come from, and not sticking too rigidly to those numbers and just treating them as some sort of golden rule, but actually trying to understand them. And that's something I don't think we do enough. And it's not just from the regulatory side. Sometimes we can be accused of code hugging on the regulatory side, and that we just say, well, follow guidance. But equally, it works the other way in terms of designers who will say, where it suits them, they might stick to numbers. I'll give an example of that. Stick to these magic numbers and golden rules when in fact they're not necessarily useful anymore. And that's not, so it works both ways, and hopefully the examples will illuminate that. I do have to say it's unfortunate. So when I first gave this version of this presentation, it was at the IFE Southern Branch at Burton Fire Station, Staffordshire Fire and Rescue Service, and Tia had arranged for operational colleagues to do a practical demonstration after the presentations in the morning, which really illuminated and kind of illustrated very clearly what some of I was referring to actually means in practice. It's difficult to do that in the context of this kind of presentation. So if you have the opportunity, whether you work for a fire and rescue service or if you can organize something with your local fire and rescue service, to actually see some of this in action, see some drills in action, see some of what high-rise firefighting might involve using say a drill tower, see what hose looks like and weighs when it's charged versus when it's not yet charged, then that's something I would definitely encourage doing. I hope one day in our industry, everyone who enters the industry has the opportunity to get some practical understanding, maybe to wear some PPE and see what breathing apparatus weighs. You don't really it's very hard to understand it until you've had that experience. And but I will try and explain. And if there's anything that doesn't seem very clear to you, do ask in the Q&A by all means. So what does magic numbers and golden rules in fire and rescue service access and facilities? So we need to ask ourselves, where do they come from? Do they still matter? What are they trying to achieve? And a further question to ask, I think, is standardization of access and facilities for firefighters more important than in other areas of fire safety? So, we do vary from guidance quite a bit in some areas, and we do find ourselves, certainly in London, going back to people and perhaps taking more of a hardline view when it comes to variations from guidance for fire and rescue service access and facilities. And I think the reason for that is that we have to train our firefighters in quite a complex built environment, which varies hugely between buildings built to different standards over many years, different types of buildings. You've got everything from heritage buildings, which can never have been expected to be built to current standards, through to cutting edge buildings involving all sorts of modern methods of construction. And for firefighters to understand this, they'll never be able to understand the full range of the built environment. They'll never be able to do familiarization visits to all of these buildings. So for them to be able to expect some sort of standardization is quite important. So I would say the answer to that question is yes. I think there's got to be more of a onus upon designers to actually demonstrate the suitability of variations from guidance when it comes to access and facilities. But that's you might have a different view, so interested to see what comes out in the discussion, particularly if you're a building designer. Very quickly as a recap, and apologies to anyone who attended the Elevate session on B5 a couple of weeks ago. Just as a reminder, this is all that the law says when it comes to access and facilities in the UK anyway. As you'll see, it doesn't say very much, and there's also this concept of reasonable facilities and protection of life specifically. So building regulations are focused on protection of life in and around buildings. They don't focus on property protection, although a lot of the measures in place for protection of life also have a property protection and business continuity benefit. But the basic legal expectation is pretty high level, as with all the functional requirements. And this question of reasonable, well, how do you know whether what you're providing is reasonable? Well, then you look at the guidance, and that's one way of demonstrating reasonability. And there is an element of preventing costs from getting too high, making it possible to actually build buildings, because you can always continue to put in further measures to reduce risk. We can never fully eliminate risk, so we have to weigh that up societally as well. Fire safety isn't the only consideration in terms of building safety. There's many other considerations. If you spend too much of your budget on fire safety, then it can come at the detriment of other elements. So it's important to keep that in mind, but equally to understand fire is a real present hazard that hasn't gone away. And in terms of how you would achieve that, so for anyone who's not already familiar, or as a recap, so recommendations of guidance, and bear in mind guidance is you're talking about recommendations, not requirements here. There's your legal requirements. Guidance such as approved document B for dwellings and buildings other than dwellings gives you one approach you can take. That's only really applicable to common building situations, so non-standard situations. You do have to keep that very much in mind in terms of whether ADB is the appropriate design guidance to use. It's also evolving, so we've got two versions of ADB essentially at the moment. We've got the current version 2019 as amended, and then we have the 2026 edition, which is coming into effect in September 2026, but after the 30-month transitional period expires. But that is available for use for designers now. We'd encourage it to be used in many cases because it includes a recommendation for multiple stairs above 18 meters, which is something certainly the National Fire Chiefs Council has been advocating for some time now. You also have the British Standards Fire Safety Codes of Practice as an alternative approach. You can use 9999 primarily for commercial buildings, but equally there's elements of 9999 that are referred back to from 9991, which has very recently been updated. So in November 2024, there was quite a significant update, if you're not already aware, to the equivalent for residential buildings. So that's important, and both of those include much reference to fire and rescue services access and facilities. If you're deviating from those the guidance either in part or more extensively, then you can follow the BS 7974 methodology essentially, which is a code of practice for applying fire safety engineering principles, performance-based design in other words, and that's supported by a range of published documents, PD 7974 series, and that includes PD 7974 Part 5. That was last published in 2014 and amended in 2020, and this is now in the process of being reviewed. So there will be a new version of this before, in due course anyway. I don't know exactly when, but that gives you essentially ways that you can vary, or you can apply fire safety engineering principles specifically in relation to fire and rescue service intervention. Something I'll definitely recommend if you haven't already read this, or if you haven't read it for a while, is CIBSIC ID, and in particular chapter 13 on firefighting. That gives a very good overview and introduction to the topic. It's not all necessarily, some of that might need an update now. There's been some evolution in the last few years, but as a general introduction, I do think that could be your basic text, and everything in CIBSIC ID gives you a very good introduction to the topics, and London Fire Brigade Fire Engineering Group, we were involved in the peer review of that, so I feel very confident in recommending particularly that chapter around firefighting, and just to understand. And it does make, although it focuses on the UK framework, it does make some reference to global approaches as well. So when you're looking at performance-based design of fire and rescue service access and facilities with 7974 Part 5, so something you need to remember at all times is building regulations guidance provides minimum recommendations. So really, there's always an invitation to building designers to exceed minimum recommendations. And designers do need to consider, and reviewers, regulators as well, are the recommendations in building regulations guidance such as ADB and 9999 and 9991 sufficient for large, tall or complex buildings? Are they sufficient for non-standard solutions, uses of innovative technologies, modern methods of construction such as mass timber? And there's a lot of good guidance now on mass timber from the Structural Timber Association in terms of how to apply building regulations in the UK and Part B and Part A to mass timber buildings. Volumetric modulars, less guidance around, and that's another example where there's changes which aren't fully picked up by guidance, in largely. Similarly with changes in technology such as battery technology, lithium-ion batteries, electric vehicles, electric powered personal vehicles, battery energy storage systems, and so on. These are all changes in our buildings that are taking place. Our regulatory framework tends to lag, tends to not keep up very well. So that's something to keep in mind. And how do you apply that? And you can't necessarily just apply the current guidance and not have to consider performance-based design elements. One area that's covered in PD 7974 is adequate firefighting water supplies. So strongly encourage everyone to familiarise themselves with the work of Paul Grimwood, which is captured in Annex A, 7974 Part 5, on providing adequate firefighting water in large, tall or complex buildings. Paul undertook his PhD research on over 5,000 building fires and looked at the amount of water that was used and provides some really critical guidance in there. And we find this is really useful, for example, for large waste recycling sites where often the amount of water required much far exceeds the 1,500 litres a minute you might expect in some other settings, many other settings. Very sadly, we lost Paul from our community last October when I went up to Staff's Fire and Rescue to present a version of this the first time. Paul's funeral had been the day before, which I was only able to attend virtually at the time, but he's really a giant. We do stand on the shoulders of giants in our industry, so I do strongly recommend if you go to eurofirefighter.com, and there's a lot of useful downloads there, including some of Paul's books, which strongly encourage people to familiarize themselves with too, particularly if you're in the fire and rescue services. There's a lot of really useful guidance in Paul's work. But performance-based design for fire and rescue service access facilities can be harder than in some other areas because it's hard to quantify, and that's where it's just so important to speak. If you're a designer, speak to your local fire and rescue service and actually ask questions around whether something's suitable. Don't just assume that something is, or assume that what one fire and rescue service does is going to be the same as another. Right, this one is a common magic number that you will see, you'll hear people refer to, and I refer to it as the urban legend of the moonwalking fire horses. And what does this refer to? So, well, we last had horses in fire and rescue services. I think the last horses were in Kensington, London, and I think they were taken out of service or retired in 1921. I've gotten that wrong, but around that time. So it's been over 100 years since we last had horses. But there is a suggestion that's been made. I've never seen any evidence to support this. I'd be very interested if anyone's got any evidence. I've had different theories, but horses being one of them, is that there's 20-meter reversing limit where fire and rescue services should not have to reverse more than 20 meters from the end of an access road descends from the time when we used horses. And the horses would be uncomfortable with when they're hitched to a fire appliance walking backwards for more than 20 meters, or the equivalent in feet from that time. And so maybe it does come from horses. I don't know. That may well be the origin. However, hopefully I'm going to be able to explain why this is still a relevant number today. So horses or no horses, let's see how this could be important to us in the 21st century. This example, and this is really where I need to restate that kind of caveat around different fire and rescue services and what they send, the resource they send to an incident. But if we have a confirmed high-rise fire in London, particularly certainly post Grenfell, the amount of resource we send is quite considerable. So first, just keep in your mind, I should do a graphic which shows this a bit more clearly for a future version of this presentation. But you've got 20 meters, it's not really to scale, but imagine you've got short length of road, you've got a building at the end of it. Now imagine you double that, say, well, you could reverse a fire appliance all the way to the fire station, all the way back to the fire station if you want. Firefighters will be very unhappy because the procedure is not as straightforward as you'd think. Fire appliance is, other than the smallest of fire appliances, is certainly any sort of pump appliance or anything larger than that is a large goods vehicle, and you need at least one firefighter, usually more than one, to act as a banksman and essentially assist the driver due to low visibility in reversing a vehicle. So, whilst you can reverse a vehicle for a long distance, you'll find a lot of very unhappy firefighters if you ask them to do that. But whereas horses might eventually get somewhat irritated, well, humans are the same, but you can, in theory, you can do it. But just imagine. So think of that road. Think of it as much longer distance, and then think about what the impact of that could be. So if we get four or more calls to a fire and some other circumstances, the response we send will likely include 7 pump appliances. So a pump appliance is what we refer to as a fire engine, what most people would think of as a fire engine. I'll show some examples of our appliances after this. We'll send 1 or more aerial/high reach appliances. So in London, that usually means turntable ladders. In other fire and rescue services, that can be hydraulic platforms, aerial ladder platforms, but essentially it's an appliance which provides high reach. I'll show you some examples. We send 2 fire rescue units. So a fire rescue unit is basically like a pump appliance, except that it's technical rescue focused, and that sends firefighters specially trained in rescue of breathing apparatus crews, firefighters with additional technical rescue training, additional equipment such as extended duration breathing apparatus. So it's another 2 large goods vehicles sent. So already we're looking at 7, 8, 9, 10 large vehicles. We'll send 2 command support units, which is basically, it looks like a bus. I'll show you in a minute again. It's a vehicle designed to support the incident commander. It comes with a crew of specialists who operate that vehicle. It has a downlink from our drone, for example, or from the National Police Air Support helicopters. It's got a whole range of different tools available. It's essentially a little meeting room as well, so there can be interagency meetings between the different emergency services on scene. We send an operational support unit, which is basically a big truck with blue lights, and that can take, for example, pallets of water on a hot day. That can become really important. Haven't even included the Salvation Army's canteen van, which they send to larger incidents. Sure, to this scale, but certainly as it gets more protracted or larger, you might have that too. We send a fire investigation unit, sometimes more than one, depending on the complexity of the fire investigation. That's a smaller van, but that's nevertheless another vehicle. We send around 5 senior officers. That's station commanders, or which is what you'd call a station manager in some parts of the UK, sometimes group commanders or area managers, borough commanders. They will respond in their own vehicles to the incident as part of the command structure. We might, if it's not at another incident, we'll send our drone unit, which is another van with the drone, the crew. So already we're looking at 20 or more vehicles, quite a lot of personnel. Now you imagine all of those personnel. This is just the initial response to a confirmed fire incident, or many confirmed fire incidents. I think that works out as 32 vehicle movements between, this is an 8-pump fire, so you've got a lot of vehicles moving around. Now you imagine that narrow, we go back again, you imagine that distance, and now you make it a narrow road longer with no turning facility. Very quickly you imagine if we need to reconfigure those vehicles, if we decide that the incident doesn't need this amount of resource, which may be the case, often that's the case, or when the incident reduces in scale, very quickly we're in a position where we're going to have to move vehicles around. That's very difficult to do if you've got all of these vehicles crammed into this dead end with no turning facilities available. So I would suggest, and I'm sure a lot of colleagues would agree, that 20 meters does have some relevance. Limiting that distance has some relevance. If you extend it by 5 meters, is it going to make that much of a difference? Probably not. But it's where you need to speak to your fire and rescue service and understand what are the implications of varying from guidance. Just thinking, oh, it came from horses, so it doesn't really matter anymore. It doesn't fly anymore. And in terms of the different types of appliances we have, so as fire investigation unit, there's the smallest of the ones I gave an example of, other than senior officers responding in their own cars. Sometimes bring fire dogs with them. You've got, and they'll often arrive later sorry, the transitions have gone a bit out awry on this. I need to tighten that up. You've got your fire investigation unit, and they need to get a certain amount of access. They'll often arrive later than a lot of the other appliances. You've got the fire rescue unit I was referring to, which again, another big red toolbox, but just without the ladders and the pump capacity, bringing all sorts of equipment. You've got the command support units, which is again a fairly large vehicle. Doesn't have to be very, very close to the incident, but we bring two, we may not need two for the whole duration. The one's got to move. If it's penned in by lots of vehicles and there's nowhere to turn around, that's tricky. That's what a turntable ladder looks like, and I'll show you an example of one that's actually deployed. Operational support unit, like I said, just a big truck basically with blue lights that brings additional supplies. So, and then a hose layer unit that's gone in the wrong place, should come to the front, but sometimes if there's the water supply is near to the incident, the nearby hydrants aren't flowing enough water for the incident, we may need to send the hose layer unit, which will basically allow us to deploy, I think it's up to 16 kilometers worth of hose, depending on whether we twin the hose or not, from hydrants further away or a water supply further away. We may have to, depending on the pumping, might have to set up a pump relay with additional fire appliances. We might even need to use a high volume pump, although it's less common. But so there's the complexity just in terms of vehicle access can be quite extensive. This illustration, I guess, is not ideal in this particular case. You've got clearly there's two directions of access, but this was from an exercise we did with University of Central Lancashire, I believe, doing some research on evacuation from high-rise buildings, high-rise residential buildings. But you can see here already, once we've got a pump appliance set into the dry rising main, twinned hose, that's not going to get moved anytime soon. It certainly can't be moved safely whilst firefighters are working within the building and you're relying on that water supply. So straight away, we need to move these vehicles around. If there's nowhere to turn them, you've got a problem. That's what a pump appliance looks like, and it's worth remembering that not only is the pump appliance there to provide a water supply, but also to provide a whole range of different equipment. It is a big red toolbox, and we have, certainly on London pump appliances, and I'm sure this is the case elsewhere, a lot of the equipment is stored in trays that slide out, which means the appliance needs more room, more width, and that makes it difficult to drive past when there's a narrow road, even if it fits within the expectations of guidance. So you've got those considerations. Okay, this one's Lego, but just to give you an idea of that's an aerial ladder platform as opposed to a turntable ladder. And yeah, once we deploy an appliance like that, you've got the jacking width to consider. It's not something you move easily or deploy quickly. Which brings me on to another topic related to magic numbers and golden rules, which is the 18-meter height threshold for a firefighting shaft. So where this comes from historically, and again, if somebody knows of a different origin, that if this has become an urban legend, this is my understanding where this comes from, though, is from an appliance, a ladder appliance, which it's no longer used, hasn't been used in the UK since the 80s, possibly the early 90s in certain fire and rescue services. Fire appliances used to carry a wheeled escape, and this was the case since the 19th century. and they would carry this essentially it's a big ladder on carriage wheels, and that was a effective piece of equipment, and in fact it was easier to maneuver in some ways than what we've replaced it with, but it was just with parked vehicles and the way that the built environment is now, it just became impractical to use. But if you take a 50-foot wheeled escape and you attach a first floor ladder of 10 feet to the top of it, you get 60 feet, and that's about 18 meters. So that's my understanding of where the 18-meter threshold for a firefighting shaft originates from. That's what an illustration of what a wheeled escape looked like many years ago. But it's just to underline the point that this is not equipment we use anymore. So we're basing our 18-meter height threshold on equipment that hasn't been used for 3 decades or more. What do we actually use now, and what have we used for decades? Well, the primary, well, we've got a range of shorter extension ladders which are used, and that's not changed for a long time. The key bit of first response risk, the frontline rescue ladder that's used by pretty much all fire and rescue services in the UK, I think all, this is a 13.5-meter ladder, sometimes referred to as the 135. Effectively reaches the 3rd or 4th floor, depending on what the ceiling, floor to ceiling heights are. I don't know if these average window heights for residential and commercial buildings still apply. This is from the old manuals of firemanship, volume on ladders, but which is actually a very good reference as well, even though some of it's now somewhat out of date in terms of understanding operational history. But when you consider that we're not going to be able to prop the ladder directly up against the building, you're looking at about 12 meters, a little bit more in terms of effective height. So the 11-meter threshold in guidance for a single stair for commercial buildings is a lot more relevant, I think, than the 18 meters. The 18 meters remains in guidance, it hasn't changed, but you do have to consider, okay, so you want to vary from what guidance suggests, then getting very stuck to the 18 meters is not a good idea. We also have turntable ladders, so that's our other type of appliance. We don't use the aerial ladder platforms, at least not in London. So we've got 32-meter turntable ladders and a few 64-meter turntable ladders. 64-meter turntable ladder, as I said, it's 32 tons. It's a large vehicle. You can't take that to every location, including in London. So that's limiting, but 32-meter turntable ladders reasonably maneuverable. And other fire and rescue services have different equipment. It was useful. I wish I could do this here. Of course, I can't on this format, but up at Burton Fire Station, our colleagues there were able to deploy their new aerial ladder platform, which was I think it was 32 meters, and show how that works and some of the restrictions involved and some of the capabilities involved. And so those are essentially the ladders we have available today. And a lot of this applies across fire and rescue services in the UK. So when we think about the 18 meters, you have to remember it doesn't apply. And so code hooking, as I said earlier, works both ways. So when we get lots of proposals, this still happens quite a bit. And I understand why it happens, because building designers think, well, guidance says I can do this, so I'm going to do this. But if you build a building to 17.99 meters to the top story height, whether or not that ends up being the finished floor level in the end, just to avoid having to provide a firefighting shaft, this is no different functionally to building a building with a top story height of 18 meters, 18.01. It sounds obvious, but the number of times you see people say, yeah, ATB says 17.99 meters is okay. Really, then that's where you have to think about that 45 kilos of equipment. This means that if you don't have a firefighter's lift, firefighters are going to have to walk up the stairs, certainly to a bridgehead 2 floors below the fire. If you're using the London high-rise standard operating procedures, they're going to have to carry their equipment to that point. They're then going to have to don their breathing apparatus, take hose to the next floor up, connect to a fire main, if indeed a fire main is provided, or they may have to run hose all the way up the stairs, and providing it's the furthest point is within the 45 meters, or yeah, no, because if you haven't got a firefighting shaft, 60 meters won't apply, and you will have quite a challenge, whereas and that 0.01 of a meter is not going to make a whole lot of difference, that 10 centimeters in reality. So be careful when proposing things like that. We'd like to see that stop, and we'd like to see designers understand what is the real implications of their design decisions. So you'll also be familiar with some of these distances. So the 18 meters between the pump appliance, parking hard standing position, and the entrance to a firefighting shaft and to a fire main inlet. The 18 meters from the entrance to the firefighter's lift, the base of the firefighting shaft for a building that has one, and the up to 60 meters distance to within a compartment hose laying distance. Bear in mind that this can be 45 meters if there isn't a suitable automatic water fire suppression system. If it's a residential building over 11 meters, you should have that now, but older buildings exist that don't have a suppression system. So you're looking at these distances. So in a minute, I'm going to talk about why is this 18 meters relevant. This is an 18 meters that does still apply, unlike the one we just talked about. So the 18 meter hose laying distance to a fire main inlet breaching, you're looking at standard length of fire hose. Across fire and rescue services, it does vary a little bit, but we're looking at typically between either 23 or 25 meters. That can be shortened to around 18 or 19 meters, 18 meters being the shortest. Basically between the instantaneous couplings, that's where the hoses connect together, and the hose itself, that can get damaged over time, and rather than just throw it away, and we are quite sustainable in how we work, and they can be shortened at our hose workshops down to a minimum distance of 18 meters, and before the hose has to be replaced. So that 18 meters is relevant. I'll show an example of what this looks like in a minute, and you might remember from the illustration earlier. We twin the hose to the fire main inlet as standard because that allows the maximum flow to the fire main inlet, which if it's a 100 mil diameter, the dry fire main will have a two-way inlet breaching. So if you increase the distance beyond 18 meters, what that really means is we may need to lay 4 lengths of hose instead of 2. So it's 2 twin lengths to the appliance, and it can be more depending on how far you've extended that distance. So sometimes we see arguments, well, the distance within the building from the entrance to the firefight to the furthest point in the firefighting shaft or to the base of the firefighting shaft to the lift is, that's only 5 meters. So we're going to extend the distance outside, but we're not laying the hose inside, we're laying the hose outside. So the impact in terms of firefighter physiology, the time delays involved, it's not the same, it's not equivalent, 18 meters outside a building to 18 meters inside a building. One relates to hose, one relates to just trying to limit the travel distance. And firefighters need water to safely commence operations, so it's not a trivial matter. We will sometimes send a BA crew in to undertake a snatch rescue where it's safe to do so, but ultimately they shouldn't be entering without water and communications, and that won't be available in a high-rise incident until we can charge the fire main. And there can be delays in terms of operating the fire main, making sure that all the outlets on other floors are closed and haven't been vandalized and so on. This illustration gives you an idea of high-rise firefighting principles. I'm not going to go into detail, but this just shows you've got the twinned hose, usually say 70 mil diameter hose to the appliance. You've got twinned hose to the inlet. So that distance, you increase that over 18, even by a couple of meters, suddenly we may end up having to lay a lot more hose. And the firefighters actually within the building aren't going to be as safe, or they can't start work sooner. And if they can't start work, the later they have to wait, the larger a fire may develop, depending on whether there's a suppression system operating. The longer casualties may have to wait, and minutes, seconds can make a difference of life and death in this kind of scenario. So other distances which you'll see in guidance, taking note of the time. So there's a 45 meter or 60 meters, depending on whether it's a distance from a firefighting shaft or between or to the furthest point within a building where there's no suppression system. This recognizes the benefits of firefighting shaft provision and automatic water fire suppression systems. You can see there's quite a significant benefit there. We're allowing a much increased distance if you have a automatic water fire suppression system, providing it's a suitable one, and a firefighting shaft, which provides all sorts of protection for firefighters. Really important to remember this has to be measured as a route suitable for laying hose. So sometimes we see kind of an assumption that if hose is being laid in a stair, it's just going straight up the middle of the stair, whereas in fact it's got to be laid on the treads typically. Sometimes we see designs, I should have put an illustration in for this one, I will for future, where you have a lobby, and between the where the landing valve outlet is located is behind a door, and then when you take into account the fact that hose is quite rigid and difficult to maneuver once it's charged, suddenly you'll find certain doors can't be opened, and that creates hazards in itself. And exceeding these limits by only a few meters can have a significant impact. Again, when we were in Burton, the firefighters there gave a very vivid demonstration of what actually is involved when you get to that point. It's 45 meters, suddenly it's not enough hose, and you need to add a length in. It's not as straightforward as just, here we go, clip another length of hose on, carry on. Got to disconnect from the pump appliance, and so it's called breaking a length is the technical term for it in fire and rescue service parlance. But essentially you're gonna have to stop. You have to retreat. Firefighters are going to retreat to a safe position, disconnect the hose from the fire appliance, add in the length at that point, recharge the hose. It's not a straightforward process, but everyone, I think designers often imagine, well, what? So it's another 5-10 meters, so it's just a matter of bringing some extra hose. Well, there's extra hose to carry, extra hose to maneuver, extra frictional loss in the hose, which is going to be quite different than the frictional loss you get in a fixed pipe like a fire main. So again, this works a lot better. You can understand this a lot better with an illustration. I'll see if I can add some illustrations next time. I did take some video when we did the. I wasn't confident the video would play properly, so I didn't put it in here. But yeah, if you can get an opportunity, particularly if you work in a fire and rescue service, speak to your colleagues on fire station, ask them if they can demonstrate this. They'll do these kind of things as part of training anyway. I strongly encourage that. And these distances aren't necessarily conservative either. So if you look at the research that was done by the Building Disaster Assessment Group, so this was after 9/11, there was a range of research done into the capabilities of UK fire and rescue services. And it was determined that actually, when you consider that firefighters, and they looked at particularly core body temperature, they measured firefighters' core body temperature and how much it rose depending on the types of breathing apparatus they wore, when they entered a fire compartment, if they were using stairs or a lift. And one of their conclusions was that, recommendations even, was 34 meters is the maximum distance firefighters should penetrate into a fire compartment to rescue a casualty, when no stair climbing is required to access the point of entry. Of course, there is always stair climbing involved because the standard operating procedure is go 2 floors below the fire. This is assuming that someone hasn't decided to omit a firefighting shaft because it's 17.99 meters. Having to climb stairs then means you'll get to the standard operating procedure, rather, you get to 2 floors below the fire, set up the bridgehead, and don BA, climb one flight of stairs, connect to the fire main, climb another set of stairs, this time with a charged hose, and then enter, might be a long residential corridor, which might be fully smoke clogged the moment you open the door to the fire compartment. Providing it's designed properly, firefighters shouldn't be exposed to untenable temperatures for firefighting, but nevertheless, they've also got to reassure residents who might be essentially trapped in their apartments at that point whilst they wait for the corridor conditions to improve. So they are expected to be able to stay put, and they might be safe in their apartments, but they're going to be worried. And that also results in a lot of extra resource being deployed. So we get what's called fire survival guidance calls, where somebody wants to go out and do their shopping, or they hear some commotion, they see some blue lights. Firstly, everyone wants to leave. They've seen Grenfell, they've seen what can happen, so they don't necessarily trust to stay put. So not only do you have people who are wanting to enter this hazardous environment, you've got firefighters who are they've got to go and fight a fire. They've got to make this environment safe. Best thing they can do is get some water on the fire, and of course there might be casualties who need rescuing. They're undertaking a lot of physiological work in what may be then suddenly zero visibility conditions in high heat. That's not a trivial factor. And then when we look at the research in the past, supports actually having shorter distances. So if you can extend the 45 meters, that's not a conservative distance in the first place. Another magic number that you'll see is the 50-meter maximum height for a dry fire main. If you've not seen what a dry fire main involves, it's essentially not an illustration of a British fire appliance, but it works. So you've got your two-way inlet breaching, you've got your landing valves off of essentially a fixed pipe, which means that firefighters don't have to lay hose up the stairs, and with the additional frictional loss, the additional physiological demand involved. And there's an illustration of a inlet breaching cabinet and a landing valve outlet. So prior to the introduction of BS 9990 in 2006, threshold was 60 meters. There's still a lot of high-rise buildings out there which have a 60-meter threshold, and it was found, there was research that was done, again under the Building Disaster Assessment Group, the Office of the Deputy Prime Minister. This was post 9/11. They found that this, in terms of the actual hydraulic capacity, pumping capacity for fire and rescue services, 50 meters was more suitable. But that really is a maximum height, and it does vary depending on the hose diameters used by a particular fire and rescue service, although appliances are, or the pumps used are relatively comparable. So that's just another area where we sometimes see variations. We see designers say, well, you know, it's only 2 more meters, we'll do a hydraulic calculation, and we'll demonstrate that this can work. But are they considering the actual effective pressure that can be obtained at the branch once you've laid out hose? Is that distance actually restricted to the 45 or 60 meters within the fire compartment? They're not considering, you know, a whole number of different factors that, so the 50 meters should be treated as the absolute maximum in our opinion. So that's another magic number, if you like, which has some basis in reality and where a few meters can make a big difference. Extended firefighter travel distances to entry points of buildings. So this is a commonly proposed arrangement in podium developments. We get a lot of these in London, certainly. This particular development is an illustration from outside the UK. I was quite deliberate not to include something that was a UK project, but for illustrative purposes, if you imagine a fire plant pulling up somewhere outside some landscaping at this point, and the fire may be somewhere on the higher levels of this purpose-built block of flats, firefighters might be expected to connect to a fire main somewhere here, but then travel with that 45 kilos of equipment upstairs, across a podium, into this building, even before they have to undertake operations within that building. Sometimes you've got, as I'll show in a minute, a bank of fire main inlets which don't have any labeling on them. They don't have any indication of what they're there for. The wayfinding is difficult to understand. This doesn't get resolved by just having horizontal fire mains, because not only are there hydraulic issues that can result from that, but you've also got the travel distances aren't resolved by that. Firefighters still have to walk that distance, even if they're not laying hose across that distance, and they still have to carry the heavy equipment to the other end. That's not at all resolved by just providing horizontal fire mains. So that's something to bear in mind. The better podium developments have all of the towers descending with access points, at least for firefighters at ground floor level, with vehicle access nearby within that 18-meter distance. So yeah, as always, as with all the other examples, considering the physiological impact for firefighters is really important. Information and wayfinding is another critical one that's starting to improve now that guidance is improving on this, but please make it easier. So we see that kind of arrangement frequently. I walk past these in London constantly, and you see a range of, it's a particularly egregious example, but there's many others out there. How do firefighters know, looking at this, which of these fire main inlet serves which stair core? Is it even the same building? It could be 4 completely separate buildings. It's kind of difficult to work with, really. So we need clear external signage, audience-specific premises information. So you've got your premises or secure information box, as we call them now. This particular example is from a subsurface railway station, but the principle's the same. So we have this box. We have to, but the first crew of firefighters who arrive doesn't have time to open the box and start reading the plans. We should be provided them in electronic format under the Fire Safety England regulations. since January 2023. Not all responsible people have provided that, and it's not always suitable information, but firefighters aren't going to be able to really do much with this information en route to an incident. They might use the electronic premises information plate information, which I have an example of here actually, but they need very simple information en route to an incident. They don't have time. They can be there within, 2, 3, 4 minutes. So a crew who arrives later one of those later appliances will open the box. The command support unit might make use of the plans in the box, but the initial crew who arrive need very clear wayfinding information on site. So yeah, that intuitive internal wayfinding signage is very important, and it may not be sufficient just to provide the basic minimum. This is another area where minimum recommendations of guidance is a relevant statement. Approved document B for volume 1 now includes some recommendations for some residential buildings, but that's the bare minimum. It tells you which flats are on which floors. But there may be other wayfinding if you've got a complex internal layout. Might need wayfinding to the sprinkler main control valve, which is not usually now accessed directly from outside the building. So for a firefighter, a standard operating procedure, certainly in London, I think for the rest of the country probably remains, we send a firefighter to the main control valve. So if they have to travel through, a whole range of corridors into a basement to find a room where they can monitor a valve, that's going to be difficult without additional wayfinding signage. And guidance or the standards only ask for a door and a sign on the nearest door outside and a sign on the door to the pump chamber. And that door is going to be locked, so we don't want to have to break our way in. For that firefighter isn't necessarily taking forcible entry equipment. So these are the kinds of considerations that just get missed quite a lot of the time by designers. So a lot of things I haven't had time to discuss, noting that it's been about an hour now, been over an hour. Some of those include extended travel distances in residential common corridors. You'll be familiar perhaps with a 30-meter single direction limit. If you're extending beyond the 15 meters allowable using BS 991 2015 with a smoke control system, suitable smoke control system and sprinkler system, or a suitable suppression system, there's some strong reasons for that 30-meter maximum limit. I haven't had a chance to talk about that. Positioning of smoke extract shafts is another one we see that causes a lot of problems, where the smoke extract shafts are located right next to the stair door. And this means when firefighters do open the doors to the fire compartment, and they may have had to travel, again, it could be up to 30 meters single direction, even if that CFD modeling has shown you're going to have tenable conditions. Firefighters then, if they need to retreat, if things go wrong, they have to retreat a long distance with smoke and heat being drawn towards them, or they have to travel. Additional firefighters come. We send a BA crew in to deal with the fire, and a second crew as a hose management team. They have a limited amount of air available, and it's only going to be less. It's going to be less if they've had to undergo more physiological work. They're going to have to retreat and be replaced by another crew if they haven't been able to extinguish that fire within the time available to them. Suddenly, that next crew may have to travel down a hot, smoky corridor, even if we use a thing called a smoke blocker quite often now, where we essentially stick a manual fire curtain in the door to try and limit the impact upon the corridor in terms of smoke and heat. But there's only so far that will go, and if you're pulling smoke and heat with a smoke control system towards the access point for firefighters, that creates a problem. Basements are another hazard which I haven't touched on, but it's really a critical one to consider. They can be quite complex, quite deep, and you can include car parks, which now will typically include electric vehicles, which can come with a whole range of unique hazards. There's modern methods of construction, which I talked about earlier, unique hazards of battery technology, and a range of other emerging risks. So I've only really been able to touch on the magic numbers and on some of the lack of suitable guidance that's available out there, but really it's important to take into account these additional risks. And there are other areas which I haven't been able to talk about in the time available. So some key take-home messages to wind up, really. Hopefully I've been able to convey the fact that firefighters have to contend with a very complex built environment. There are numerous different hazards they have to deal with, and we cannot possibly train our personnel in all the different possible variations of the built environment. It's just not possible to do that. And in London, we have the possibility to do a bit more of this with whole-time firefighters exclusively in Other fire and rescue services with a lot of retained firefighters, there's a limited time available for training as well, familiarization and so on. So please help us if you're designing a building, help us by providing consistency in firefighting access and facilities. We don't expect you to be experts in fire and rescue service operations, just like you don't expect us to be experts in all aspects of building design. But if you do seek to, or you absolutely have to deviate from the recommendations of guidance, which happens, we can't build every building that's the same box. We don't seek to do that either. Do make sure you understand the impact and please speak to us at the earliest opportunity. And I know that's easier said than done with the resources that are available, but we do encourage that and we do try wherever we can to facilitate that. If you've got something that really deviates, particularly when it comes to access and facilities, speak to us when you're at planning stage, concept design stage. Don't wait until something's being built, which is often what's happening at building reg stage. I know with the Gateway 2 regime and for high risk buildings, at least we have an opportunity to look at a design before it's being built. But even then, you've done detailed design. It can have quite a significant impact if we haven't had that chance to have input earlier. And I know again that's limited. But planning stage is something we do seek to make representations on planning applications. And in London, we have the London Plan. I know that's evolving as well. So speak to us is the plea. And maintain a situational perspective. And this applies just as much for designers as those of us in fire and rescue services looking at the designs produced by others. So when you consider your design or a building that you're managing, if you're a responsible person or principal accountable person, or if you're risk assessing, consider that from the firefighter's perspective. What does a firefighter have to contend with? Well, it might be 3 a.m. Imagine this, you're roused from sleep, it's 3 in the morning, you might have had a really busy, tiring day, and you rush to a building chances are you've never been there before, even if there's an intent to do familiarization. It might be the crews who are nearby are at another incident at that time. So you go there, you've never seen this building before. You're inevitably confronted with a chaotic and dynamic environment. Everything's changing. Residents may be mass self-evacuating from a high-rise building because they see blue lights. Their residents' WhatsApp group has been contacted. There's a fire on the 3rd floor and people will start to evacuate. So you've got this to deal with when you arrive. Yeah, occupant behavior can be unpredictable. You don't have time to interpret 80 pages of a fire strategy or a bunch of MEP plans that someone just stuck in the secure information box thinking they were being helpful. So, and the information en route is limited. You have to assess this scene whilst carrying a lot of heavy equipment over what can be a considerable distance. You then, once you've done all of that, and that sounds challenging enough as it is, you're plunged into a hazardous, high heat and low visibility environment. You've got limited air supply to work with. That's the type of context in which a design variation or a system you're maintaining could be tested. So the question to ask is, are you making our firefighters' already hazardous job as easy as it can be? And I think that's my take-home message. If this is the only thing you get out of this presentation today, and I think this is really important to consider for those of us, I think for Green Book colleagues around the country, if you work for a fire and rescue service and you don't have that experience as a firefighter, and even more so for people designing buildings, a few meters here and there, or that just comes from horses. Don't don't take that approach. Think, what is the impact? And if you don't understand the impact, find out. And there are ways to learn. So that's the message really. So I think that brings us not too far over time, hopefully, to an opportunity to go through some Q&A. I think there might only be 2 questions, which is less than there have been in the past. But if you think of questions now, please do send them over. I'll hand over to Tia.
No, brilliant. Thank you so much, Ben. That was great. So just have a couple of questions. See what you think to these. First one is, if several of these numbers come from equipment used in the past, why are the figures not updated to represent today's equipment?
Very, very good question. I ask that question myself a lot. It's when we respond to government consultations about guidance, we've made the point about the 18 meters many times in the past. When government tries to use this to update guidance, we constantly make the point, we think 11 meters is more relevant today. The 18 meters comes from equipment that we no longer use. So that point has been made by the National Fire Chiefs Council, by London Fire Brigade. Guidance, it would take a bit of work to review all of guidance and actually, because there's a knock-on impact. It's not just a question of, oh, we can just reduce this threshold height for a firefighting shaft. There are impacts from that in terms of the government wants to build 1.5 million new homes, there's a cost implication and there's a range of implications. So whilst we encourage that, we understand that's an evolving piece, and there's things like approved document B, the bases of approved document B. There is a lot of research ongoing looking at that. So maybe that will change in the future. It's only something we advocate, but yeah, it should have been, I think. And it's not a point, it's a point that has been made. So that's the best answer I can give you, I think.
Brilliant. On measuring hose lengths up stairwells, where is a reasonable point on a building plan to measure that around the inner banister or the centre line of the stairwell?
I suppose taking a conservative approach to that, I would say centre line of the stairwell is reasonable enough. Basically, be conservative, I guess is my best answer on that. Essentially, it would be easier to illustrate this, but hose, you get quite a long bend radius on hose once it's fully charged, and that's going to sort of hug the outer wall of the staircase rather than the inner banister. So actually the center line is probably not sufficiently conservative either. Just assume the hose is running around the longest point up the stair. That's probably your best bet. And bear in mind, there's multiple hose lines you might be looking at. So you've got the hose from the floor below the fire, and then when you enter that lobby, or the stair landing, we will usually run two lines of two jets, and a primary attack jet and a safety or covering jet. The second team as soon as we can, so that firefighters have got cover if they have to retreat. So if you were being fully conservative about this, again, guidance doesn't really tell you to do this, but I would suggest find the most conservative way to measure that. Hopefully that helps a little bit, but yeah, it's difficult to explain without an illustration or a practical demonstration. I will look around, see if there's any good videos or any photos I've got from exercises or anything to show what that looks like for a future presentation. But thank you for the question.
No, thank you. I think that's all the questions. Oh no, we've got another one. Apologies. How do you see emerging technologies such as drones, robotics, or smart building systems affecting firefighter access in the future?
That's a good question. I don't have a crystal ball, so I suppose I can only speculate on this point, but there is going to be a change. I think smart building systems certainly is one where I think there's a lot of potential for making firefighters' lives easier, particularly with providing information. So there's the potential to provide more real-time information on an incident. Certainly now, building systems are becoming more and more complex, and what's often missed is providing that information to firefighters in a way they can understand it. It's often designed for a maintenance engineer or commissioning engineer to understand. Like, for example, on a smoke control panel, we've gone from having panels which just had LED lights and buttons that you would press, easily operable by gloves, to touchscreen technology, which is not in itself something which shouldn't be used, but does need to consider the display of the information needs to be considered for that, and en route information for firefighters. So I've had conversations with various companies producing digital twins of buildings, for example. If you imagine BIM models used in design, being able to essentially scan a building and provide 3D walkthroughs for firefighters, either when they're doing familiarization, they haven't got time in the day to go to all buildings, but if they can look at a familiarization for a building at a desktop setting and watch a 3D walkthrough, that's something which potentially has benefit, but it has to be designed in such a way that the information is suitable for firefighters. Similarly, the way that information is presented, rather than just providing a whole range of plans, providing that information in a way that's just the most intuitive for firefighters when they're looking at a mobile data terminal en route, that they can understand that. So it's not even the most smart building systems, but actually the technology we have now, but using it in a way that's suitable for firefighters, I think is the first point. Drones are used, so we have a drone team. It's a especially valuable tool for a whole range of different incident types, high-rise incidents. In the past, we would either have to rely on the National Police Air Service helicopter, or we would rely on using a turntable ladder or other high-reach appliance. With the 64-meter turntable ladder we have now has essentially CCTV cameras on it, which allow us to get that view remotely from the scene. But in the past, we would rely on information relayed from firefighters at the top of the the ladders, and so now we can use, we've got the capability to do that without relying on other agencies. We bring our drone. We've got infrared technology there. We can see how a fire, thermal imaging, we can see how a fire is evolving through smoke and so on. So this is, we are making use of innovative technologies. Robotics, I'm sure there's a place. Anywhere where you can send a robot into a building, into a hazardous environment instead of a firefighter. Right now, I don't think we certainly don't have robots which can rescue casualties safely, but could go into a building and actually assess gain situational awareness of firefighters. I'm sure is something which probably will be used more in the future. I know probably there are fire and rescue services around the world already trialing that technology. Certainly firefighting drones are used in Dubai and other places, but we don't have that currently in the UK, I don't believe. We've got, trying to think of other technologies certainly that get used. I mean, positive pressure ventilation fans is something we've been using we haven't used until more recently. We're trialing in London at the moment, but in other parts of the country, such as Tyne and Wear, they've been using that for a long time to essentially bring smoke control with firefighters and operating that to be able to assist firefighters and produce and any trapped occupants in creating a safer environment. So I think that the future is very promising in terms of using different technologies. I'm sure we've got members of our team who've looked at large or machine learning, large language model type approaches, loath to say AI as such, but what is often considered to be artificial intelligence, looking at how that might assist fire engineers. I'm sure there's places where that can be used to assist firefighters as well in terms of emergency response. So the future it is evolving. If you just look at our PPE and breathing apparatus, how that's evolved over the last 30, 40 years. So there's been massive changes. It's lighter weight, which makes a massive difference. The duration is sometimes improved. The telemetry systems available, just so that the information an entry control operative has at the bridgehead in terms of the amount of air available and how firefighters are responding to the incident remote from them, making sure that they're safe, knowing that they can evacuate them easily at a press of a button. All of that is available to us now and is being used. So if we've had that much progress now, I'm sure there will be plenty more as time goes by. So appreciate, I don't know if that's the answer you might have been expecting, but yeah, I think there is. How exactly those technologies will affect firefighter access in the future, I can't say, but I think they almost certainly they will, and they already are.
Brilliant. Thank you, Ben. I think that's all the questions. But thank you, Ben. You've been a great presenter today. You've been a great presenter today. And as always, your presentations in particular, this one are very interesting and educational. Thank you so much. And before we end the webinar today, I just want to take a moment to advertise the Yorkshire and Humberside branch's next webinar, which will be taking place in September. We'll be taking a short break in August, but we'll be back with a webinar on dangerous substances and explosive atmosphere regulations, also known as DESIR, as well as approved code of practice L138. So keep your eyes peeled on our socials for that and the link to join. But many thanks again to Ben and everyone for joining today.
Thanks, Tia. Thanks, everyone. Thanks to the IFE as well for providing this platform. And yeah, looking forward to seeing some of you at the Elevate seminar on operational firefighting tomorrow afternoon. But all of this will be available as recordings, so hopefully as many people as possible can access.
Perfect.
Thanks, everyone.
Bye-bye.
Bye.